In this concept, we're going to talk about isosceles triangles and their properties. So the two congruent sides of an isosceles triangle are called legs, and the two congruent angles of an isosceles triangle are called base angles, as shown in the figure below. So this is an isosceles triangle, ABC, and then we have these legs, right, which are both, around the vertex, so the vertex is between the legs, right? And the base angles are opposite to the legs, okay? The sides opposite the congruent base angles of an isosceles triangle are congruent. Okay, so if we start from the base angles now, if angles B and C are congruent, then sides AB and AC are congruent. Then we know it's an isosceles triangle. Let's look at this example. In the figure above, what is the measure of segment AB? Well, we can clearly see that angles A and C are congruent, right? So if these two angles are congruent, then segment AB is congruent to segment CB, or segment BA is congruent to segment BC. Then segment AB is also 5. If this is 5, then this is 5, right? So AB is equal to 5. Another rule to note for isosceles triangles is that if a line bisects the vertex angle of an isosceles triangle, then it is also a perpendicular bisector of the base. So if we have line AD bisecting angle A, okay, in an isosceles triangle, right, both legs equal, then this line AD is also a perpendicular bisector of the base BC. So these two angles will be perpendicular, and these two sides, or these two segments, will be perpendicular, congruent. So segment BD, okay, segment BD, it will be congruent to segment CD. Okay. Let's look at this example. The triangle above is an isosceles triangle. Find the value of Z if AD bisects angle BAC. So AD is a bisector of angle BAC. So these two angles are the same. Okay, and it's an isosceles triangle. So that tells us that AD is also a perpendicular bisector of the base, which means that segment BD is congruent to segment CD, which means that Z has to equal 3. Right? Z has to equal 3. Okay. Next we talk about equilateral triangles. So an equilateral triangle is a triangle that has all sides as congruent. Okay. So side AB here is congruent to side BC, which is also congruent to side AC. Okay, AB congruent to BC, congruent to AC. Then the triangle is equilateral. Another way to look at equilateral triangles is through the angles, the interior angles. So all angles of an equilateral triangle are congruent with a measure of 60 degrees each. They have to equal 60 degrees in an equilateral triangle. If they are equal to 60 degrees, and obviously equal, then the triangle is equilateral. Okay? And here we have our exercises. Please pause the video, work on these, and come back for the solutions. Okay, here we want to show that triangle ADB, which is this triangle, is congruent to triangle ADC, which is this triangle. Okay. All right. So two triangles, we need to show them congruent. Well, we could start with what's clear to us, right? And that is this. So ABC is an isosceles triangle, so these two legs are equal. So we have segment AB is congruent to segment AC, right? And then the angles, right? So we can clearly see that these two angles are equal. So we have angle BAD is congruent to angle CAD. Okay. And we have segment AD, right? So AD is congruent to, well, itself, right? So it's actually shared by both triangles. So it's part of ABD and part of ADC. So guess what? Now we have side, angle, side, right? Therefore, triangle ADB is congruent to triangle ADC by side, angle, side. Okay? Second exercise, find the measure of angle C in the triangle below. So this is clearly an isosceles triangle. Okay, and so the legs are congruent. So then both of these angles will have to be congruent, right? The base angles. So I can write 4x plus 4 equals x plus 36. Okay. Minus 4 minus x minus 4 minus x. So minus x's go away. 4x minus x is 3x. 4's go away. 36 minus 4 is 32. X equals 32 over 3. Okay? Which is about 10.67. So then to find angle C, we have x plus 36, which is 10.67, plus 36, which is 46.67 degrees. Okay? And this is it for this concept. See you in the next video.